All right, good afternoon, everyone. I handed back your quiz, and I try to make detailed notes so that you can understand the problems that you missed. But near the end of the class, I do want to kind of walk around and see if there have been any individual questions, because your test tomorrow, the first part is going to look like that. It's going to look like what you just took. So let's talk about your test for tomorrow.
8 and 9 on the quiz.
I'll go over that with you individually. Okay. So if you look at the test review, which we did last Thursday, we did the first page, and your test is basically going to be this length. It's going to be part 1 being 1 page, and then part 2, which we're going to go over today, being the 2nd page. So the procedure for tomorrow is going to be this. When you walk in the classroom, you're going to put all your book bags up front. You're going to have your calculator, but you're going to have your calculator underneath your desk, because the first part you're going to take is going to be non-calculator, okay, which essentially is just going to be what you just took with the quiz. Very much the same type of questions, okay? So you'll take that first, and then when you are finished with that portion, you'll turn that in. When you turn that in, you'll pick up the second portion, the second page of the quiz, which is calculator portion. It'll be on a different color sheet. You pick that up, and then that way I can see by looking around that if you have a color sheet, then you should have a calculator on your desk, because everyone may be working on a different case, okay, which is fine. Okay. So that will be the procedure. Now, the second part, the calculator portion, is going to resemble more of the first quiz that you took. So let's see if we can spend some time going over those types of problems. Okay. So in your packet, let's go to part 2, the very last page, page 42. Okay, so just to refresh your memory, anytime that I want to convert from degrees to radians, I'm going to take my angle, which is in terms of degrees, and I'm going to multiply it by what? Yeah, pi over 180. And that will allow me to convert something that is in from degrees to radians. Now, when you do this and you want to give an exact value, leave the pi out of your calculator. Just multiply it with like 1 times 1 over 180, and you can add the pi manually onto your paper. Okay. But if I want to go from radians to degrees, I'll take my radian measure and multiply by the reciprocal, right? So now I want the pi's to go away, so times 180 over pi. Okay, try that. Try number 1 and 2. This one is with calculator, right? Right. So this is part 2. That's right, yeah. So this is with calculator, so have your calculators out, and then you can. All right, questions with number 1? Okay, try number 2. Okay, any questions here? Okay, so 3, 4, and 5, let me read the directions here. It says, state the quadrant in which the terminal side of the angle lies and find its reference angle. Answer the questions in the units that it is given. So as a reminder for reference angles, you're always going to be involving the x-axis depending on where your terminal angle is. So if my terminal angle is in the first quadrant, then there's no change. Whatever your angle is in the first quadrant, that is your reference angle. If your angle is in the second quadrant, then you're going to be involving 180 to help you get to that reference angle. Remember, your reference angle is always positive, and it's always between 0 and 90 degrees. Okay? It's always in the acute angle. So here, if it's in the second quadrant, just subtract 180. Okay. If your angle is in the third quadrant, then you're still going to be involving 180. But now you're going to subtract the larger minus the smaller. And finally, if you're in the fourth quadrant, you're still going to involve the x-axis, but instead of subtracting 1 from 180, you're going to involve 360. Let's say your angle is 340 degrees. Your reference angle will just be 20 degrees. Okay, go ahead and try 3, 4, and 5. Oh, and by the way, if it's in if something is given in terms of degrees, then you can use 180 and 360. But if your measure is in terms of radians, then you're going to be subtracting either from pi, involving pi, or you're going to subtract involving 2 pi, depending on which quadrant you're in. Okay, so number 3, state the quadrant that your angle is in, the terminal side is in, and then find your reference angle. Yeah, give me a second. I'll put it up. Yeah. Okay, so number 3, quadrant 2, right, 105 degrees. Subtract 180, and we get 75 degrees. For number 4, negative 310 may not be recognizable initially, but remember we can always either add or subtract 360 or add or subtract 2 pi to get it to a measure that's more recognizable. So once we get it into that range between 0 and 360, we realize that 50 degrees is already in the first quadrant. So 50 degrees is your reference angle as well, right? So if your terminal side is in the first quadrant, there's no adjustment needed to be made. That is whatever angle you have there is your acute angle, is your reference angle. Okay. Question so far? Number 5, 9 pi over 5. Where is that located? All right, so 9 over 5, it's not quite 2, right? 9 over 5 is a little bit less than 2. So you know it's going to be less than 2 pi, so it's going to be in that fourth quadrant, right? So I simply need to subtract from 2 pi. You can also do common denominators, 10 over 5 minus 9 over 5. Okay, questions so far? Yes?
Not about this, but for the test tomorrow, will it be like the quiz where we're going to involve unit circle?
Exactly, right. So you're not going to need the unit circle for the second portion of it, but for your first part, it'll literally look very much like the quiz that I returned to you. First page will be your quiz, back page will be a blank unit circle. For the calculator portion, you're not going to need a unit circle. You have your calculator, so you don't need it. Okay. All right. Are we okay? 3 through 5? Okay, let's look at number 6. It says there's a distance measuring equipment. It's standard, is a standard avionic equipment on a commercial airplane. This equipment measures the distance from a plane to a radar station. If the distance from a plane to a radar station is 220 miles and the angle of depression is 38 degrees, find the number of ground miles from a point directly below the plane to the radar station. Okay, so even if you have a word problem where the diagram is not drawn for you, the nice thing is that you know that these types of problems will be involving a right triangle. So you just find out how to draw a right triangle that will fit the description of this problem. Okay, so there's 2 ways that we can draw this. So I want to kind of make sure I go over them. You can choose either one, but just want to make sure you're able to see it from both perspectives in case you draw it one of these 2 ways. So let's say we have a plane. Okay. Flying in the horizontal direction, and let's say we drew it this way. And then the radar station is down here. Okay. So that's one way to draw it. Okay. Another way that we can draw this is we can have the plane I'm drawing, maybe I have the right triangle this way. Okay, both works.
Does it matter what way you hit it?
It doesn't, but there is something I want to point out that I think is yeah, so that you're not, especially with the angle. So I want to talk about that. But I want to have both diagrams in front of you so I can fill them out with you and see how they work together. Again, you only need to draw one triangle, but I want to kind of show you both of these. All right, so this radar station is 220 miles from the plane. So where can we put 220? Good, it's the hypotenuse, right? Either here or here. Either one's fine. Okay, but not the horizontal, right? We're looking at that direct distance between the plane and the radar station. Okay, it says the angle of angle of depression is 38 degrees. What did I say before with angle of depression? Just treat it as the what? Angle of elevation. Okay, so I want to talk about that for a second here. Angle of depression and angle of elevation. Whatever angle you draw, make sure that there's a horizontal segment included in the angle. Okay? If there is not a horizontal segment included, then that is not the correct angle. Okay? So typically we have drawn our triangle like this, kind of right side up, and I would say, you know, don't put the angle here, put the angle here because it's the same thing as angle of elevation. Okay? But I think a better description of this is you can put the angle above, but a horizontal length has to be included for the angle. So here, there's a horizontal angle. There's a horizontal component to build that angle. Here, you can do angle of depression because there's a horizontal up here. Before, I would say never put it here because, you know, this triangle is not drawn in a way where there's a horizontal. So this would not be a good place for angle of depression. But this is okay because there's a horizontal included. So I want to make sure that we see that. Okay. Angle of depression, angle of elevation, yes, they are. You can put it in either place, but if there's no horizontal as part of the angle, then it's not the right place. Okay. All right. Find the number of ground miles from a point directly below the plane to the radar station. So when I see the word ground miles, I think of horizontal miles. Right? It's like miles that we would travel if you're on the ground, so it's going to be a horizontal mile. So either you can call it X here or here, right? So it doesn't have to be on the ground as long as it's horizontal. That's enough for ground miles. That's right, good. So it doesn't matter how you draw the triangle, there's only one trig function you're going to use, which is cosine. Okay, try that. Okay, any questions here? Yes.
I plotted sine.
Okay, yeah,
I
cosine.
wrote down cosines in my calculator.
Yeah, and then make sure that your calculator is in degree mode. Okay, degree mode. You're not gonna. Chances are you're not gonna use radian mode for this quiz. So just make sure you are in degree mode. Okay, are we okay with number 6? Any questions? Okay, let's look at number 7. So this is going to be S equals R theta. This is an arc length problem. So let me define the pieces, the parts for this formula. S equals R theta. Okay, what does S represent? Arc length. R is the radius. Then theta is your angle. Now, theta is all, if you're coming from this formula here, theta is always in terms of which unit? Good. It's always going to be in terms of radians. And that, I think that threw off some students on the quiz because they got a value for theta, but they did not see pi in it, and they just want to put pi because you feel like if it's radians, there's got to be pi as part of SB showing. So just understand that whatever theta you get, that already has radian. That's already your radian measure. You don't have to include or add anything to it. Okay. Okay, so we have a pendulum that's 22.9 centimeters long. So this pendulum is going to kind of swing back and forth in an arc path. So we can think of this as the radius, because if it were to go a full circle, it would represent the radius of a circle. Okay, the pendulum travels 10.5 centimeters. Which part of this diagram is this going to be a part of? Yeah, this path, right? This curved path. Distance is your arc length. Right? Find the degree measure of the angle through which the pendulum swings. So let's find theta first, and let's see what adjustment we need to make. Okay, try that. You have your formula, you have everything that you need, and now I can find theta. Okay, what you guys get for theta initially? And this is in terms of what? Radians. Do I need to put a pi after it? No. Okay, leave it alone. Whatever value you get, that's your radian value.
Can I just round the 8, 5 to 9?
Yeah, that's fine. Well, that's fine. That's fine. But is this what the problem is asking for though?
No.
Okay, degree measure. So how do we make that adjustment? How do we get from radians to degrees?
Multiply.
Multiply by?
180 divided by pi.
Good. It feels weird not having pi to cancel out, but this will convert this unit to the proper form that we want. Let's say 3 decimal places, and I will specify on the test.
26. I got 26.299, but I also did 0.5 times.
0.59. Yeah, I think that's the danger of rounding a little too soon. If you can have a little bit more value or decimal places, it'll increase your accuracy at the end. Does that make sense? Yeah.
So on the calculator, when I did the 180, well, I put pi out, I put like 180 for 1. I got 8 degrees. So when I put pi instead of 1, I got 26. You know how you usually tell us like leave pi out of the calculator?
Yeah. Okay. So leave pi out of the calculator if you're trying to represent an exact value. Does that make sense?
Oh,
But here we're rounding. We're trying to find a specific numeric degree measure. So in this case, we do want to plug it in. Right. Okay. Any questions? Okay, I'd like for us to get in a little bit more practice involving right triangle trig. So on the worksheet that you picked up, go ahead and read number 1 and try that. Okay, hot air balloon is tied to the ground with 2 straight ropes. One rope is directly under the balloon and makes a right angle with the ground. The other rope forms an angle of 50 degrees with the ground. Find the height of the balloon. So we know the height is the vertical component of our triangle. You can give it any variable you want. So we have to involve the 50 degrees, the x, and the 110. What did you use? Sine, cosine, or tangent? Sine, okay.
Oh, this is a picture that I don't have a sheet.
Oh, did I run out?
I'll just look on it.
Okay.
Sorry. Okay.
I put positive right there. I still I think.
Okay, any questions with number 1? Okay, number 2. Communication company is building a 30-foot antenna to carry cell phone transmission. As shown in the diagram below, 50-foot wire from the top of the antenna to the ground is used to stabilize the antenna. Find the measure of the angle that the wire makes with the ground. So what's different about this problem here? Yeah, we're looking for the angle. We're still going to set up a trig ratio, but now what process is involved if we have to solve for an angle? Inverse, right? We got to do inverse. But first, start off building your trig relationship first. Right. Decide whether you want to use sine, cosine, tangent.
Okay, and then inverse. It is sine. It's the inverse of sine. I know that. I know how to do it. Yeah, I know how to do it. Equals.
Wait, that is the nearest edge.
I had 9.5. Oh.
Yeah.
I actually did. I actually did.
No.
You multiply by 12. You're asking for your answer and you're pointing at your answer. Wait, I still don't think it's
No.
Not in inches.
Is that not right?
Yes.
Can I see the answer? Just like slide it for me.
Yeah.
Yeah, let's come over here.
37 degrees.
37.
You like it?
36. That's what I got. I just didn't round it. This is not good. I got it right. I just didn't round it.
No, it's an inch.
Oh yeah, sorry. Yeah. 37. It says the round's the nearest degree, so 37 degrees.
36.3 inches.
Oh. I know, that's exactly what happened.
I lost points on my
I'm done. Not.
Okay, back page.
Oh, yeah. Yeah.
It says the nearest inch, but just keep it in feet.
I told you.
It's too much trouble.
So when
I'm so mad. Well, it's the instructions that you know, it's telling you to
Okay, so draw your diagram. You know your diagram is going to fit into the shape of a right triangle. Your ladder is going to be, the hypotenuse is going to be leaning against the wall. It says how far, find how far the base of the ladder should be from the side of the building and how far up from the side of the building it will reach. So you're finding two variables. You're finding both the horizontal and the vertical. Find one first, and then we'll worry about finding the other one. So I drew my triangle this way. I would just go ahead and solve for either x or y. And once you find one value, then you can worry about the other one. But don't try to solve both at the same time. You're going to need two separate processes here. So I decided to solve for x first. So I used cosine.
Wait, don't show us yet.
All right.
And if other people did it, then congratulations. I did. Everything. No, I'm kidding. That's such an ignorant thing to say. I literally did that right now. Sorry, freaking.
Your elders.
And that's about word. Freaking stupid.
So once I find one side, what option do I have to find the other side? Pythagorean theorem or trig? All right, so it's up to you. Once you have two sides of a right triangle, you can feel free to use Pythagorean theorem, but you can use sine to find the other value as well. Yeah, so that's yeah, so three feet, yeah, sorry.
I was right.
You didn't say every.
I was right. Okay, straight.
Mhm.
For instance, if it was to the nearest stage, you would convert your answers to stages, right? Like by multiplying both of them by 4. Like.
Yeah, that's right.
Yeah, okay.
That's right. Yeah.
I'm dying on the road.
Yeah.
Shut up. Sorry.
Okay, number 4. Any questions up to this point? Number 4, number 3.
Wait, I want to check if I did that right. I got 9.511 and 3. Oh, you're supposed to round it to the nearest inch. Then I got.
No, round to nearest feet. I made a send me a put inches.
I didn't read that part.
Okay, number 4.
I didn't read the entire part.
I have this in 2 parts. First part is just what the problem says, but the second part, if the height of the tree is 40 feet, same base, find the angle of elevation.
Height of the tree isn't 40 feet.
Oh, see, this one's the 10th.
Yeah, that's part B. Just do part A first. Okay, so part B is saying if the diagram.
Like not including part A.
Yeah, sorry. Don't make it clear.
Oh.
So you're completely forgetting about part A, that it's not.
Oh, you're just, wait.
Yeah, part B, you're solving a different problem.
Oh,
Just so, because I wanted you guys to practice solving a side and solving an angle.
that makes more sense.
I was so.
Because I thought I got it wrong, and then I solved it wrong.
Oh, yeah.
That means the top end.
Yeah, it's the top.
Yeah.
Yeah, so B, you're gonna find theta.
Got it.
Find theta, you're gonna do reverse operation.
Sorry. Don't know what that
You didn't say it.
Okay, what you guys get for part B?
I got 69.444
I'm so sorry.
Degrees.
I got that right.
Yeah.
degrees, same difference.
Oh, I did it right.
What?
Thank you.
Guys, I have one more for us to do. Any questions up to this point?
We have one more?
Yeah, one more that I did not include on this sheet. Do you remember on your quiz, you had that double triangle within a triangle thing? Okay, so let's practice. Wait, does anybody still need to look at number 4? So number 4, B, tangent of theta equals 40 over 15. I need to solve for theta, so I need to do inverse tangent. And make sure you're in degree mode, 69.44 degrees. So hopefully you can find some empty space on your sheet that you have. And let's read this problem here. So this problem says you are standing on a plateau that's 800 feet above a basin where you see two hikers. And you know that you're going to draw the same way. You're going to draw two triangles, triangle within a triangle.
Can you draw for us? I'm a visual learner. I'm a visual learner.
In this case, you do want to treat angle of depression as angle of elevation, right? You're going to.
The distance, are the lower ones always farther, right?
That's right. Lower one is the further one. That's right. Okay, ultimately, we're trying to find this distance, right? The distance between the two hikers. But you're not going to solve for x initially. You're going to have to find the base of the big triangle, find the base of the small triangle, and you got to subtract the difference. So I'm going to split this up into two smaller diagrams. So after I find y and after I find z, what am I going to do with those two values? Subtract them, and that will help me get that missing part I'm looking for.
I got the right answer.
So you're using tangents for both of the triangles because you have the opposites and the adjacents involved. So you find the two bases, and you subtract them, you get that missing piece that I'm looking for that x. Okay, any questions?